let's see if we can run through an example of this second type of improper integral. So I have 4x over x squared minus 64 to the 1/3 power, dx. Notice that, and I have a little side note here, there is a vertical asymptote at x equals 8. All right? So anytime you're doing one of these definite integrals now, since we have these improper integrals in play, you need to check to see if either of these two endpoints cause this denominator to become 0. Any value that causes the denominator to be 0 for this type of function, there will be a vertical asymptote. So if we have the denominator is equal to 0, there is a vertical asymptote at 8. This is an improper integral. All right? To save myself some space, I'm going to erase this note. But this is an improper integral. And so we're going to rewrite this as a limit statement. The upper limit of integration is where the vertical asymptote lies. So I'm going to use b as the variable. Also, since it is the upper limit of integration, you only approach that upper limit of integration from the left. So no matter what value I'm doing here, it has to approach from the left. Anytime it's b, it's from the left. Anytime it's a, it's from the right. What value am I approaching? I'm approaching 8. So it's not guesswork. You can cobble together what this limit expression must involve. It must involve the upper limit of integration. It's approaching that number. Upper limit of integration in this context are only approached from the left. And then we alter this to be 0 to b. b is now an unknown constant. I have 4x over x squared minus 64 to the 1/3. And so what's our procedure? Our procedure, this is limit, b goes to 8 from the left. What do we have? We evaluate the antiderivative as usual. So I'm going to leave this alone, evaluate the antiderivative. It's an ordinary U substitution. So du is equal to 2x minus 64, the derivative is 2x dx. I don't want 2x dx, I want 4x dx. So multiply both sides of this equation by 2. This implies 2 du is equal to 4x dx, which is exactly what we wanted it to be, 4x dx. All right, so the substitution is now exact. All right, so what do we have here? This is the limit as b approaches 8 from the left. What do we have? The antiderivative is the antiderivative. We don't know that we're going to change the variable. X squared minus 64 to the 1/3, that's u to the 1/3 in the denominator. U to the 1/3 in denominator, 4x dx in the numerator, that's 2 du. All right. And what are the limits of integration? Well, we don't know. We've changed from the x variable to the u variable. We don't know the limits of integration, so we're going to put in 2 dummy limits of integration. Anytime you're doing this improper integral and you change using a U substitution, you must put in dummy limits of integration. When we come back to the original x variable, we will come back to the original limits of integration. And so what do we have here? This is the limit. B goes to 8 from the left. The antiderivative here, let's go ahead and write all the details here. C, D, this is 2, this is u to the negative 1/3. All right, I've just rewritten the expression because I'm going to use the power rule here in just a bit. This is my limit statement. Where's my eraser? This is the limit statement. And the antiderivative is 2 u raised to the 2/3 power. Divide by 2/3 means we multiply by 3/2. And the 2's cancel. I'm sorry, yeah, everything's squared away. So the 2's cancel, so we have 3. That's evaluated from C to D. So I have u to the 2/3. The 2's have canceled. I still have this 3 remaining. Evaluate at the upper minus evaluate at the lower. So this is the limit. We can do this. We can do this. We can go back to the original variable. If I go back to the original variable, u is x squared minus 64. This is to the 2/3 power. But now I've gone back to the original variable, which means we may go back to the original limits. The devil's in the details, and this is loaded with details, but it's not brutally challenging. Keep your wits about you. So now we need to evaluate. So what's the rule? Compute the antiderivative. Check. Got that. Evaluate at the upper minus the lower. We're going to do that here in the next step. And then evaluate the limit that we inherit from that. So when you evaluate the upper limit of integration, this is 3 times, right? This is b squared minus 64 to the 2/3 power minus, evaluate at the lower limit of integration, 3 times 0 squared minus 64 to the 2/3 power. And now substitute b is equal to 8. So we've found the antiderivative, substitute the values for the values for b in the upper and lower limits, and now evaluate the limit. So this is the limit. Well, we're going to evaluate the limit, so I can stop writing LIM. So if I substitute 8 in for b, 64 minus 64 becomes 0. That falls out. 64 minus 64 becomes 0. That falls out. All right? So this is 0 minus. Now evaluate this. Well, that's a constant. Evaluate minus. This is 3, 0 squared minus 64 to the 2/3. Which is negative 3 times negative 64 to the 2/3 power. What is negative 64 to the 2/3 power? I'm going to run out of space. Let me just barely include that in here. This is negative 3 times. What's the third root of negative 64 is negative 4. Third root of negative 64 is negative 4. But that's squared. So this is negative 3 times negative 4 squared is 16. Negative 3 times negative 16, I don't know all the mathematics in the world, but 3 times 16 is a number. 48, is that right? And so our final value is 48. So there is plenty to do, and there's nothing for it. There is plenty to do. But the procedure is straightforward. And so you should be able to work through that, I think, using all the skills that we've developed so far.